We're now entering chapter 2, which is about oxygen and sulfur compounds, and we're referring to the functional groups when we're talking about this. So when we're looking at alcohols, we're looking at compounds that have an OH group inside of it. Notice this line next to the O. That means that's where the rest of the carbon compound is bonded. A phenol is the same general idea, except with the OH where this line is, you're going to have a benzene ring. Remember, a benzene ring is shorthand with a hexagon with a circle inside of it. It's alternating double single bonds, but they realized that these double bonds were actually being shared throughout the compound, and so that's why you have this circle there instead. So when we're naming alcohols, notice the word alcohol ends with an OL. All of your names are going to end with an OL. So if we're looking at methane, which is a single carbon, here's the word methane. If we take away that E and put an OL there instead to put methanol, that's how we name it for IUPAC. Remember, IUPAC is the systematic way of naming it. Systematic. Okay, here's ethane. 2 carbons give us eth. Single bond gives us A and E. Instead of having the E there, we're going to chop the E off and put the OL there instead. So ethane becomes ethanol. And there's our OH group. Now the common way of naming this, if it's at the end, the OH group has to be at the end, they look at the rest of it as a substituent. So that means CH3CH2 is ethyl. So they just put ethyl alcohol, or CH3 is methyl alcohol. This only works if the OH is at the end. So when we're naming, first of all, figure out how many are in our longest chain. 1, 2, 3. That's where we get propane from, or prop. A and E comes from the single bonds. So for this one, it started off as propane. We took off the E and we put on the OL instead. The next one has 4 carbons. That's where we got bute from. Originally it was butane. Take off the E and put in an OL and you get a butanol. And then finally 6 carbons gives us hexane. Take off the E, put in the OL, and that's where we get the hexanol. With alcohols, you have to say where the OH lies. Therefore, you have to say which carbon it's on. You're going to start numbering from the side that's closest to the alcohol. For instance, we will start numbering from the right on this one because that's where the alcohol is. So on the first carbon from the right is the alcohol. So 1 propanol. The next one we're going to start counting from the left because the OH group is closest to that side. That is on the second carbon, so 2 butanol. And on the third one we're going to start counting from the right because it's closest to the OH group, which is on the second carbon. And that's how we get those. So once we have the 3 carbon chain in the OH group, the 3 carbon chain in the OH group, there's nothing else to write, so that one's done. 4 carbon chain with an OH group, 4 carbon chain with the OH group, that one's done. 6 carbon chain, the hex, OH group, OL, saying where it is. However, we have this substituent here that's not been labeled. This is a methyl group. So in this name, we're going to have to include the methyl. We're going to keep counting from the right because that's the side that the OH is on. So 1, 2, 3, 4, 5. So on the 5th carbon of the 6 carbon chain, there's a methyl group. And on the 2nd carbon of the 6 carbon chain, there's an OH group. So it's 5-methyl 2-hexanol. Alright, so let's name some more. This one, 1, 2, 3, 4. We're starting off with butane because 4 is bute. That E gets removed and we put an OL there instead, so it becomes butanol. We want to count from the side that has the OH group. That means we're going to be counting from the right. On the first carbon is the OH group, so it's 1-butanol. The next one, 1, 2, 3, 4, 5, is originally pentane. Remove the E and put an OL there instead. So pentanol. And then to figure out what the OH group is, here's the OH. We're going to count from the left because that's the closest. So on the second carbon, there's an OH group on pentane. We have one more substituent here that's not accounted for, and that is the third carbon has a methyl group. So 3-methyl, 2-pentanol. The last one, remember all these bens are carbons, so that means we have 5 carbons there. So there's our pent. Because they're in a circle, it's cyclo. It would be cyclopentane, but we're going to change the E to an OL. The reason why I didn't use phenol, remember, in order to be phenol, it has to have a benzene group, and that's not the same. This is cyclopentane, except now it's cyclopentanol. We don't have to put a number here because numbers are not affected when it comes to cyclo groups unless there's multiple ones. And there we go. There's our numbers. And there's the rest of our substituents and our final answer. Now let's move on to phenols. Notice that phenol is a hexagon with a circle inside. That's referring to the 6 carbons alternating the double bonds. And then those double bonds are shared amongst them, so that's why they get the circle. Phenol means that there's an OH group bonded to it. That means when we're naming it, we're going to use the word phenol in the process. These are just some examples of common ones. Here's some more examples of things that you might be a little more familiar with. Vanilla, this is the compound that's in vanilla. Here's your phenol group right there. Here's an ether because it's surrounded by carbons. And this is an aldehyde. Eugenol is actually in cloves. You have an ether in that one too. And you have a double bond. So you can see that these functional groups keep coming up. So when we're naming it, you need to start with the longest chain. Well, for our purposes, the longest chain is going to include the phenol group, which is why phenol is in the name. However, in the process, you'll notice that we have other substituents. This one, for instance, is chloro. So we start counting from where the OH group is. 1, 2, 3. So on the third carbon of that benzene, there's a chloro phenol. This is a bromo. 1, 2, 3, 4. On the fourth carbon, there's a bromo group phenol. 3 chloro, 4 bromo. So now we're going to go back and try to draw these out. So let's see. Pent means 5, so that means we have 5 carbons in a row. On the third carbon, there's an OH group. So 1, 2, 3, OH. All the rest of these are hydrogens, because the hydrogen is the filler. Ethyl alcohol. This is the common way of naming it, which means that the alcohol is going to be at the end. So ethyl is 2 carbons. There's an alcohol at the end of it, and all the rest are hydrogens. And then finally, instead of we see phenol. Phenol means it's a benzene ring with an alcohol group. So we draw the hexagon with the circle inside. And here's our phenol. On the 4th carbon of this phenol, 1, 2, 3, 4, there's a methyl group. There you go. Thiols are slightly different than hydroxides, than alcohols. Notice there's sulfur there. So alcohol is an OH. Thiols are an SH. If we look at the periodic table, here's oxygen. Sulfur is right underneath it, so they have the same number of electrons. And once again, this dash means this is the rest of the carbons. So this is bonded to a carbon right there. Thiols tend to be extremely smelly. For instance, natural gas on its own has no odor. However, they add this a thiol to it, so that way you can detect a gas leak if there is one, because you'll be able to smell it. Garlic, thiols in garlic, it's in onions. You'll also notice it has like an egg smell sometimes, like a rotten egg smell even. When we're naming them, you are going to name it as if it's a regular chain. Except you're going to add thiol to the end of it. So methane, and then you have thiol, so it's methane thiol. If you look at this one, 1, 2, 3, that's usually propane. Since it has an SH on it, propane thiol. And you have to say where it is on the chain. So start counting from where the sulfur is. So we're going to count from the right. It's on the 1st carbon, and that's where they get the 1 from. For this one's far more complicated. Once again, we have propane, but we have a double bond, which making it propene. Remember to count from the sulfur. That means 1, 2, 3. On the 2nd carbon is the double bond, so 2 propene. Then on the 1st carbon is the sulfur, 1 thiol. And finally, we have ethers. Ether is surrounded by carbons, an oxygen that's surrounded by carbons. So if we compare, alcohol is a carbon, an oxygen, and a hydrogen, whereas an ether is a carbon, oxygen, carbon. And you name it as if it has 2 substituents coming off of the oxygen. For instance, this is a methyl group. This is also a methyl group. So 2 methyls mean it's dimethyl. And you're just going to end it with ether, saying that that oxygen is surrounded by 2 methyl groups. On this one, we have ethyl. And this side we have methyl. Do this alphabetically, so E comes first. That becomes ethyl, methyl, ether. And then finally, as another example, this is a methyl group. This is a propyl group. Combine them alphabetically, methyl, propyl, ether. So, going back from the beginning of the section, 3-pentanol. So, pent means 5 carbons. On the 3rd carbon, there's an OH group. 1, 2, 3. All the rest of these are hydrogens. Ethane, thiol. Thiol means we have an SH on it. Ethane is 2 carbons. Because of the thiol, we had to put that there. And all the rest of these are hydrogens. This one didn't have a number saying where the thiol was because it didn't have a choice. No matter what, it would have been on the 1st carbon. And then diethyl ether. So ether means it's surrounded by carbons. Diethyl means that there's two ethyl groups. So C, 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 C. And these are all surrounded by hydrogens. And there's your final answer again. Just to give you a little bit of background on ethers. Diethyl ether was used for centuries as an anesthetic. Knock you out. However, what they realized is that it's very volatile. Volatile does not mean violent. Volatile means it goes from a liquid to a gas very easily. Well, once it turned into a gas, it became very flammable, which made it cause a lot of explosions. Not very good for the ER room, for the ER, or the OR. So they started developing different anesthetics, ones that didn't have so much hydrogen in them. So ethane is one, penthrane is another. And it does essentially the same thing without the flammability of the diethyl ether. And that is the end of the first section of chapter 12.